So sorry. Looking at equation 3, I can write x1 dash is equal to x2 from this equation. Equation 3. Okay. So this is the equation. From equation 1, the derivative of velocity is acceleration. So I can write x2 dash is equal to 1 upon m. This is from equation 1. So now, how many state variables I had? State variable matrix, which was x, happens to be x1 and x2. X dash, which is dt of x, happens to be x1 dash, x2 dash. Alright? What is the input? Input is simply f. So this is a scalar. But we'll see that the matrix is not scalar. Never. So let's write this more elaborately. So that means on this side, we have 0 times x1 plus 1 times x2 plus 0 times f. That is this equation. Next, x2 dash is 0 times x1 plus 0 times x2 plus 1 upon m times f. So now, if I was to write this in a matrix form, so I will write x1 dash, x2 dash, 0, 1, 0, 0, x1, x2, plus 0, 1 upon f, which resembles x dash equal to ax. So I have represented a block on which a force F is acting, and we are trying to measure the displacement and velocities. That model, physical model, has been written as a state space model. And this is how you write it. Okay. So now, as an exercise, I want you people to try to write a state space model for a physical phenomena which is described as follows. A d cube x by dt square plus dt cube plus dx by dt plus x is equal to. So if this is something that I give you, let's say that there is a physical system that can be modeled like this. You can just probably, let's add t here and let's add. Now, this is a question to someone and anybody. Try to model this as a state space model. You have 5 minutes, and then I'll ask questions from at random, trying to get the values of state. What is the state variable matrix? What is A matrix? What is B matrix? So on and so forth. Okay, so start, and we'll just see each other in another 5 minutes to discuss this problem. Okay, start. So could you do it? The problem? I'm waiting for a reply from anyone. Arvind,
यस सर ट्राइंग सर
करा?
सर ट्राई कर रहा हूँ
कितने स्टेट वेरिएबल्स ले रहे हो?
सर 4 ले रहा हूँ
4 लोगे. क्या है ऑर्डर इक्वेशन का?
3 थर्ड ऑर्डर सर
So there is no need to take 4. 3 will do. Anyway,
ओके सर
continue. करो. Okay. कमल,
यस सर
सॉल्व हुआ?
नहीं सर
कोशिश कर रहे हो या फिर यू आर वेटिंग फॉर मी टू सॉल्व इट?
हाँ सर कोशिश कर रहा हूँ
करो. Is there anybody who could get that representation? Actually, it should not take more than this. मानस, हुआ कुछ?
सर कर रहा हूँ सर
Daksh, could you get an answer?
Sir, halfway through.
If there is anybody who's done it, they can just unmute and tell me that they've done it, and then we can have a discussion. The reason why this small exercise is important is that later on we are going to be modeling some physical systems where things move a little, or maybe they get rotated a little. So d2x by dt square will become d2 theta by dt square. So in essence, things are going to be the same, but you should be able to write state space model for differential equations, because most of the mechanical systems are modeled using differential equations. In fact, every system is modeled using differential. But you'll have second order, you'll have first order, you'll have what kind of system it is. Anyway, is there anybody who could do it? Are you people even solving? इतना टाइम लगना नहीं चाहिए. कशिश,
सर एक बार आप बता दीजिए, समझ नहीं आ रहा मेरे को.
is there anybody who could do it? At times there could be a little bit of confusion to begin with, but let's solve it. Okay. So here we go to this problem. So as I said that it's a third order differential equation. So wisdom tells us that it'll be tackled with 3 state variables. So let's begin. Let me just say that x1 is equal to x. That's the first state. Then x1 dash, let's say, is equal to x2. So that's basically dn dx1 over d. So this is the second statement. Then I have x2 dash is equal to x3, and this is basically d2 x1 over dt square. Then I have x3 dash, and that is simply x1, and x1 is equal to x. So you can just write it as dx by dt, d2x by dt square, d3x by dt cube, and so on. So I have now three state variables. So x matrix is x1, x2. Now x dash then obviously becomes x1 dash, x2 dash, x3 dash. Now let's write the equations for x1 dash, x2 dash, and x3 dash. So x1 dash is x2 from this equation. I have just rewritten it. x2 dash is simply x3, and this is the equation that gives me this. Now let's look at x3 dash. So if I substitute everything that I have written here in the equation which is given to me, this one, then I can write a x3 dash plus b d2x by dt square becomes basically x3 plus c dx by dt is x2. So now basically what I'm doing is that I'm writing the differential of the third state variable in terms of state variables. So the idea is always to try to write the differential of every state variable in terms of state variables. So I proceed and I write this as dx1 is equal to eu. I'm dropping the time index. So I get x3 dash is equal to minus d over a x1 minus c over a x2 minus d over a x3 plus e times u. So now I have a equation.
सर ई बाय ए नहीं होगा.
Sorry, e by, thank you. E by. So this is the first equation where x1 dash is related to the inputs and state variables. This is the second equation which relates x2 dash x2 dot with all the state variables and input, and this is the third equation. So now I'm ready to write it in the form in which I'm expected to write. So let me rewrite the equations. x1 dash is 0 times x1 plus 0 times plus 1 times x2 plus 0 times x3 plus 0 times 0. x2 dash is 0x1 plus 0x2 plus 1x3 plus 0u. x3 is, now this is, we have to be careful because everything comes here, minus c by a x2 minus b by a x3 by a. So now let's write it. So I'll say x1 by a c by a c by a so x dash AX. That's your answer. So this is how you model, let's say, a third order differential equation in the state space model. So I guess now it's clear uh, the methodology with which we can write state space model, and as an exercise, perhaps you can look into a problem. Fourth, I mean, this is something which should now be easy for you. Uh, just write them as small, because we use the the capital ones for the matrices. So let's say so now this is a differential equation, and I hope that you people should be able to write the state model for this. We are not going to do it in the class, but this is basically what I wanted you to understand. Most of the systems that you see in nature, most of them can be modeled using a second order differential equation, because there'll either be some displacement or there'll be some rotation, because of which there'll be angular acceleration instead of linear acceleration. So instead of d to x by dt square, you will have a term like d to theta by dt square. But essentially, the fundamentals remain the same. So the motivation behind this lecture today was to be able to write differential equations. First, of course, to give you a broad outline of the state space modeling equations, and then to write a differential equations in a state space model. Later on, when we proceed further, which will probably be in the next class, we'll see how a state space approach can be utilized on electrical circuits. Electrical circuits you have studied. In electrical circuits, we look at basically circuits that will have R, L, and C. The reason why I will take these circuits is because we know that the voltages in an inductor are something proportional to di by dt, and the currents in capacitors are proportional to dvc by dt. So these are first order in differential operators, right? So we'll move from first order differentials, and then we'll go to slightly more complex systems where second order differentials are used, and we'll be able to see that we can write state space models for these kind of systems. And you'll also see that this state space modeling, how we relate this to signal flow graph in subsequent lecture. So state space modeling can give us signal flow graph as well. We'll see how we can do that, and we'll look into these electrical problems only, and we'll try to see how we can make this. This can then give us transfer functions. And once you have transfer functions, you can also kind of create a block diagram. So basically, things are not in isolation. You studied block diagram representation, you studied transfer functions, you studied signal flow graphs. They are not different from state space approach. It is just an approach. It's just a method to write a system differently. The beauty of a system is that it should naturally give you other ways of modeling a system as well. So you will see that state space method, which can be applied to both linear as well as nonlinear systems, can give you signal flow graph, can give you transfer functions, and can also give you block diagram representation. And that's basically.
Sir, can you show the full? Sir, can you show the full question?
I'm sorry.
Sir, can you show the full question so it's not visible?
Which is not visible?
So the question you gave at the end of the class.
Oh, it's not really so much of a question, but yeah. So I think probably it got. So it is a d4x by dt4 plus d cube x by dt cube plus c d2x by dt squared plus d dx by dt plus ex equals f times u. This is basically what you can, it's not a, it's just a practice problem for you, and it would be nice if you can kind of solve it and see that you get a similar kind of an expression. And you can just clearly see that in this case there will be 4 state variables. You can see that this A matrix is going to be 4 cross 4. You can see that this B matrix is going to be 4 cross 1. So I pretty much have the solution in your hands now. But I end this lecture now, and we'll see each other in control systems next week. But I hope that now there is clarity on how you can write a state space model for a differential equation that is given. Right? Okay, thank you. Yeah.
सर आपने जो प्रीवियस क्वेश्चन में यूटी को यू ले लिया था सर, वो कैसे लिया सर, समझ नहीं आया।
नहीं, यूटी को यू ही लेना है और क्या लेना है? इट इज एन इनपुट. आई हैव नॉट रिटन टी, so I am not understanding what is your confusion. Can you explain me? UT is so U is basically a 1 cross 1 matrix here. That's it. मनाली क्या समझ में नहीं आया? एक बार फिर से बोलो तो I think maybe I can clear the doubt, but it should not really be a doubt. Let me just थोड़ा सा गड़बड़ हो रहा है. Just a second. I just need a little bit of space. Yeah. So when I write x dash equal to ax plus bu, then I say that all these things are matrices. X dash is a matrix, A is a matrix, B is a matrix, X is a matrix, and U is a matrix. But in the problems that I gave, the input was UT. So what I did was that I dropped the T subscript and I wrote it as U. So this U is basically this U, except that it is only 1 cross 1 matrix. So that is the reason why I wrote something like this, 0, and then there was 0, and then there was E by A U. Because this U was figuring only in the equation of one of the state variables. So that is what basically it is. And just practice the problem that I gave you, and it will automatically be clear. So, look at the problem this way. The differential equation that I've given you, which is of 4th order, try to write it in this form, and then try to figure out what is the dimension of this matrix, what is the dimension of this matrix, what is the dimension of this matrix, and what is the dimension of this matrix, and see if they are relating to each other, because AX and PU must be of the same dimension. And in the problem that I've given you, the dimension should be 4 cross 1. For X dash, it could be 4 cross 1 for X. U is 1 cross 1, so you know what B should be. It should be somewhere like 4 cross 1. Okay, so that's it. And I'll see you in the next class. Tomorrow we have a DSP class. We'll meet you there. All right. Thank you. Bye-bye.